Hello, everybody. We're going to get started here pretty soon. Let me go ahead and share my page with you. There we go. All right, we're going to be going over more SAT and PSAT practice for tonight. To this week and next week will be the last PSAT and SAT live stream that I'll do, and then we will resume with other pre-algebra and algebra after that. So let me just make sure everything is looking good on YouTube. Okay. I think we're okay. Okay, great. Just want to make sure that my audio is working well as well. Okay. All right. So again, we're going to go over PSAT and SAT practice questions today and next week. You can find the links for all of the questions that I'm going over in the description. They are all printable from the College Board website. So let me actually go down to the next page here. So here's the website as well if you want to look at it there. But the link is in the description. And we're going to start off with the PSAT. We're doing the 8-9 Bundle 1, Module 2. So when you're looking for those, scroll all the way down. Module 2 is all the way at the bottom because I believe it has the reading information first and then the math. There are 2 different math tests. So we are doing Module 2. I'm getting some errors. Sorry, hold on just a second. Maybe because it's just getting started. I don't know. I keep getting error messages about the internet connection being poor, but we have a lightning fast internet, so I'm not sure why this keeps happening. Sorry, give me just a second. If you're here, please let me know in the chat. That would actually be really helpful for me to see if you can hear and see me okay, if it's coming through okay. Okay. I am still getting an error message, so I don't know if this is. I'm watching it on YouTube on a separate device, so I think we're okay. All right, cool. We are going to press on. Okay. There we go. Okay. All right. Sorry about that. All right. Thanks for sticking with me. Let's go ahead and get started with our PSAT bundle. So we're going to start on number 19 here. We've got scientists collected fallen acorns that each housed a colony of the ant species I don't even know. Ohioensis. I don't know if that's right. And analyzed each colony's structure. For any of these colonies, if the colony has X worker ants, the equation y equals 0.67x plus 2.6, where 20 is less than or equal to X, which is less than or equal to 110, gives the predicted number of larvae Y in the colony. Okay, well, I'm going to pause there for just a second because I know if I'm a student looking at this, that is just like a lot of information. So let's break down what they're actually saying here. So, what we've got is they're telling us that Y is the predicted number of larvae in the colony. So, that's what Y represents, and X represents the number of worker ants. Okay. So we've got kind of those are the two pieces of the puzzle that I think are really going to be concerned with. And the number of worker ants has to be somewhere between 20 and 110. So I just wanted to kind of that was a lot of information. So I just wanted to break that down before we moved on. If one of these colonies has 58 worker ants, which of the following is closest to the predicted number of larvae in the colony? Okay, so this is kind of a complex way of asking if we have this equation and we know that X represents the worker ants and we have 58 of them, what do we get as the predicted number of larvae when we substitute in that number for X, right? Which of the following is the closest to the predicted number of larvae, which is what Y represents. So we are substituting in that X. Instead of X, we're substituting in 58 and then solving. That's really what it boils down to. So let's go ahead and do that. I'm going to pull up my calculator here. Okay, there we go. So 0.67 times 58 plus 26, that gives us Y would equal 64.86. And that is, did I do that right? Oh, I'm sorry, 2.6. I forgot a point in there. I knew that didn't look right. That equals, Y would equal 41.46. So there's a lesson for us there. The decimal is very important. So this one is closest to A for our answer on that one. All right, let's go on down to 20. What number is 40% greater than 115? Percentage is an area that a lot of my students that I work with, they really struggle with. But I always teach this method. It's kind of foolproof, and no matter which pieces of the puzzle they give us, you can substitute the numbers into these spots, and then you don't have to do as much guesswork if you have to multiply or divide. So whenever we're working with percentage, we're using the percent over 100, and that's going to equal the part over the total. Now, we do have to do a little bit of work on this one ahead of time before we start substituting these numbers in, because it's asking what number is 40% greater than 115. So we can look at this two different ways. We're trying to find 40% of 115. So 115 is like our starting number. And we're trying to find 40% of that to then add on to 115. So this is how we can set that up. Let's set that up before I tell you the second way that we could do this. So 40%, that's our percentage. That's going to go in the percentage spot. It's always over 100. And then 115 is the total, and we want to find the part. We want to find that 40% of the total 115. So this is one way to set up our proportion. The other way is to find 140% of 115. And what this proportion will do, is it will eliminate the need to add on whatever we find. If we find 40% of 115, we would then have to add that number to 115 as a second step later on. But here, the 100% is the 115, and then the 40% is the extra 40%. So I'm actually going to solve it this way. Once we have it set up like this, then we simply cross multiply. So 140 times 115, that gives us 16,100. But then we're going to divide by 100. We're going to divide that 16,100 divided by 100, just move the decimal over 2 spots. So that gives us 161. So that gives us the total without having to do that second step of adding. We already sort of pre-added that 100% into our percentage. All right, let's go on to 21. For the values j and k, the ratio of j to k is 11 to 12. If j is multiplied by 17, what is k multiplied by in order to maintain the same ratio? Okay, so whenever we're working with ratios, we're always dealing with multiplying and dividing in order to get other numbers that are proportionate in that same proportion as that ratio. So if j, let's set up a little table here. Because of the order that they have them, j to k is 11 to 12. So the first number goes with j, the second number goes with k. If j is then multiplied times 17 to get whatever this new number is, then we would also have to multiply times 17 to get the new number for k in order to maintain that same ratio. And we don't even have to do that multiplication. That's not what they're asking for. They're just asking what is k multiplied by. So it would have to be multiplied by 17. All right. On to the next problem. Let me see. It doesn't look like we have any questions. Okay. Emmanuel purchased a certain rare coin on January 1. The function f of x equals 65 times 1.03 to the x power, where 0 is less than or equal to x, which is less than or equal to 10, gives the predicted value in dollars of the rare coin x years after Emmanuel purchased it. This is very similar to that first problem, the problem about the ants that we did already. So let me just highlight a couple of things here. So x represents the number of years. So this exponent represents the number of years after Emmanuel purchased it. So that tells us. And then again, let me do maybe a different color. The f of x gives the predicted value. So however many years he has this coin, we do this math, and then that's going to tell us the predicted value of that coin. So what is the best interpretation of the statement f of x is approximately equal to 82 in this context. Okay, so they've replaced x with 8. So that tells us that what they're calculating is 8 years, right? So this is he's in this scenario, he has had this coin for 8 years. And then once we do all of that calculation, it's equal to 82. So this is the predicted value. So let's look through our answer choices and see what we have that kind of matches that. When the rare coin's predicted value is approximately $82, it is 8% greater than the predicted. No, okay, that's already out. That's not it. When the rare coin's predicted value is approximately $82, it is 8 times the predicted value in dollars on January 1. Okay, that's still not it. What we're looking for is with as far as the 8 goes is that it's been 8 years time. Like that's how long it's been. From the day Emmanuel purchased the rare coin to 8 years after, okay, that's promising. After Emmanuel purchased the coin, its predicted value increased by a total of approximately 82. Close, close. This is saying it increased by a total. So that's what it's saying, whatever the coin's value was at the beginning, now we're adding $82. And that's not what they told us that this function represents. This function represents the predicted value. So we don't have to add anything on. It's just that is what the coin is now worth, is $82. So hopefully D is at 8 years after Emmanuel purchased the rare coin. Its predicted value is approximately $82. Yes, that is exactly what we're looking for. Okay, great. Let's go on to the next page. Again, you can find all of these at this website. The link is in the description. This is the PSAT 8-9 Bundle 1, Module 2. All of these are free worksheets that you can look up and print out. All right, let's take a look at 23. All right, so we've got a table here. The table shows 3 values of x and their corresponding values of y, where n is a constant for the linear relationship between x and y. What is the slope of the line that represents this relationship in the xy plane? Okay. So we're looking for slope. Slope is rise over run, or another way of thinking of it is a change in y over the change in x. So let's look at our y values. We don't know what n is. We don't know what that value is, but all of these are just being added to n. So n is a constant, and it told us that here. N is a constant in each of these. So what is the difference? What's happening each time we jump from one row to another? So let's see. We've got 184 minus 92 is 92. Okay, so we're subtracting 92 when we go down here. And then, yeah, that makes sense because we're not adding anything to n in this third row. So we've subtracted 92 again. Okay, now let's compare that with what's happening over on the x side. So from -6 to -3, that is a positive 3. And then from -3 to 0, that is another, so I shouldn't say positive 3, that's an addition of 3. And then from -3 to 0, we're adding 3 again. So again, our change in y is -92. Our change in x is 3. And looks like A matches that. We have a -92 over 3. So that would be our slope. All right. Okay. Just over here to this cylinder. Okay. The figure shown is a right circular cylinder with a radius of r and a height of h. A second right circular cylinder, not shown, has a volume that is 392 times as large, just underline that, as the volume of the cylinder shown. Which of the following could represent the radius r in terms of r? Okay, so they're using big R, large R for the new cylinder radius, and then the small r for this cylinder's radius. and the height of h, so large H, that's the new cylinder in terms of small h of the second cylinder. Okay. All right, so let's first talk about the volume of a cylinder formula. Volume of a cylinder is big B, base times height. And whenever we have capital B like this, that is talking about the area formula of the base shape, whatever the shape is. In this case, it's a cylinder, so our base is a circle. So the area formula for a circle is pi r squared. So that's that part. Pi r squared is what big B represents. And then we're going to multiply that times h, right? The height of the circle. So this is how we would find the volume of this cylinder. Sorry, I think I said circle before I meant cylinder. Now the new cylinder, so this is this one. And so now the new cylinder, a second right circular cylinder, not shown, has a volume that is 392 times as large. So we're going to take this formula, and it's 392 times pi r squared times h. Okay? So let's look at our answer choices down here, because I'm seeing that they're representing each individual part, the radius and the height. So what we're looking for is which of these would give us 392 times pi times small r squared times h, right? So let's just multiply 8 times 7. This one's going to give us 56 times pi r squared h, right? So that's not it. That's not what we're looking for. And I just got that 56 by multiplying the 8 and the 7. So then let's see, what is 8 times 49? 392. So we've got 8r times 49h, 392 pi r squared h. Okay, so this seemingly looks like this one. However, we would also, the trick here is that whatever we're multiplying times the r would also have to be squared. So this is actually, and I should have done that for this one too. It's still not going to be the right, because this is not enough. So this is actually going to be, let's go back to answer A. So this would actually be 64 times 7, which is 448 pi r squared times h, right? Because whatever the new radius is, that's also going to be squared. And so that means that both the number and the radius has to be squared. So for this one, we would actually get 64, which is 8 times h times 49, which is 3,136 pi r squared times h. So that's not it either. All right, so we're going to square this. So that is 7 times 7 is 49 times 8, which is what we got before. So 392 pi r squared times h. So that looks like a winner to me. This one, again, we would square. That would just be way too big, because these are the same, the 8h and 8h. So that's going to be even larger. So we're looking at C. That was a tricky one. That one I could see stumping some people. All right, let's go to 25. Each side of a 30-sided polygon has one of 3 lengths. The number of sides with length 8 centimeters is 5 times the number of sides n with length 3 centimeters. There are 6 sides with length 4 centimeters. Which equation must be true for the value of n? Okay. Let's make a table here. So, because they've given us a lot of information. We know that we have 30 sides. And there are 3 different lengths amongst these 30 different sides. So we have one length. Let's do like a table. One length that is 8 centimeters. And that the number, so we've got the number of sides. And then up here, we've got the lengths. There we go. Okay. So we have some 5 times the number of sides n. So we don't know exactly how many sides that is, but we just know that it's 5 times n. And that many sides is a length of 8 centimeters. With length, oh wait, sorry, I think I misread that. The number of sides with length 8 centimeters is 5 times the number of sides n with length 3 centimeters. Okay, so I think that's still, we can keep that. We just now know that there are n sides. We don't know how many that n represents, but n sides that have 3 centimeters. And then the 8 centimeter sides, there are 5 n of those. And then there are 6 sides with length of 4 centimeters. Okay. I think having the lengths be, different dimensions of lengths, I think that's throwing in just an extra little bit of confusion in this problem. So that's why I really wanted to lay out this chart. But we do know that all of these together for, I don't want to put total up there, but we do have a total of 30 sides. Right? So if we added all of these number of sides, that would equal 30. And then we can do some simplifying here. We get 6n plus 6 equals 30. And then we could go ahead and solve that, but that's not exactly what they're asking for. They just want to know which equation that we would use. So that would be it. All right, we're going to go on to SAT in just a minute, so stick around for that. Let's see. All right. Okay, so this is the SAT Bundle 4. If you're wanting to look that up yourself and have that printed out, we are down. I've been trying to do 2 pages each week, so this is the 3rd week. So that's why we are down to starting on number 19 for tonight. So let's go ahead and get into number 19. The function f of x equals 1/9 times x minus 7 squared plus 3 gives a metal ball's height above the ground f of x in inches, x seconds after it started moving on a track, where 0 is less than or equal to x, which is less than or equal to 10. Which of the following is the best interpretation of the vertex of the graph? Okay. So luckily, this equation is in vertex form. It's called vertex form because we can just look at the equation and see the vertex. So we usually refer to this as the vertex is HK. And this, whatever number is being added or subtracted with the x inside the parentheses here, that gives us negative h. So we always do have to change the sign of that one. And then this, whatever is being added or subtracted outside of the parentheses, that is k. We do not need to change the sign of that one. So this gives us a vertex of 7, 3. right? So that is our vertex. So then another thing that we notice about this is that we do have a positive a value. This number, in this case it's a fraction that's out in front of the parentheses, is positive. So that means that our graph is opening up, right? These types of problems give us this parabola shape. And so then that means that this point right here is at 7, 3. That's our vertex. That's sort of like that point where it starts to change direction. So let's take a look at our answer choices and see so the meadow ball's minimum height was 3 inches above the ground. Yeah, X seconds after it started moving on a track. The metal ball's minimum height. Okay. The metal ball's minimum height was 7 inches above the ground. The metal ball's height was 3 inches above the ground when it started moving. The metal ball's height was 7 inches above the ground when it started moving. Which of the following is the best interpretation of the vertex? So the minimum would be 7 inches because it looks like, let me give myself a little bit more room here. If we were to graph this on a coordinate plane, so we've got, oh, no. I'm sorry. It's got to be A because Y is how high the ball would be, and 7 would be how long it took. 1, 2, 3, 4, 5, 6, 7. Yeah. So right here, they told us that X is the seconds that it took. So it took 7 seconds for it to reach 3 inches. So the Y coordinate is the inches above the ground. So A looks like the correct choice for that one. All right, let's take a look at the next one, 20. In triangle JKL, cosine of K equals 24 over 51, and angle J is a right angle. What is the value of cosine of L? Okay, let's get a picture in here. So told us that it's a right triangle and that angle J is the right triangle. So J, we'll name it JKL. All right, so then with trig functions, if you don't know this one, there's SOHCAHTOA. So it's just kind of a little mnemonic device to help us remember what sides we're looking at and which sides we're using for sine, cosine, and tangent. So O is for opposite, H is for hypotenuse, and A is for adjacent. So it's telling us that cosine of K, so this is our 90-degree angle right here. Cosine of K, this angle, is looking at adjacent over hypotenuse. The hypotenuse is always across from the 90-degree angle. So that's our hypotenuse over there. The adjacent side would be the leg of the triangle. So one of the sides of the triangle that creates that 90-degree angle, we call those the legs of the right triangle. So it's the leg of the triangle that creates the angle that we're talking about. So this is the adjacent side. So what they're telling us is, since A comes before H in our little mnemonic here, is that 24 is this side length KJ, and then 51 is the hypotenuse. Okay. So now let's switch gears to the value of cosine of L. So now we're talking about this angle down here, L. So they're still asking for cosine, but now the adjacent angle to angle L is this angle, and this is the one that we are trying to find. We don't know this one yet. But because it's a right triangle, we can use Pythagorean theorem to find this other side length. Whatever it is, the cosine of L is going to be whatever x is over 51 because it's still over the hypotenuse. 51 is still that second number that we need. But let's go ahead and use Pythagorean theorem. So we've got 24 squared plus x squared, or you could say b squared, whatever, equals 51 squared. So let's use our handy dandy calculator. So we've got 24 squared is 576 plus x squared equals, and then 51 squared is 2601. All right, and then we're going to subtract 576 from both sides. So that gives us x squared equals 2025. And then we can't stop there. We need to find the square root. We need to square root both of these because we want to know what just x is, not what x squared is. So square root of 2025, that gives us 45. So this side length is 45. And so that is our missing number for our ratio there. We can reduce that by 3. Those are both divisible by 3. 45 divided by 3 is 15. And 51 divided by 3, 17. Great. So probably going to be looking for a reduced fraction on that one. All right, let's go on to the next problem. If you guys have any questions, then feel free to drop those in the comments. Okay, 21. In the given equation, b is a positive integer. The equation has no real solution. What is the greatest possible value of b? All right, so we don't know what b is. We just know that it is a positive integer. So if our equation has no real solution, that means that if we were to use the quadratic formula in order to find our solutions for this quadratic, that means that whatever is in that radical, in that square root, that would have to be negative because that would give us an imaginary number. So let's write out the quadratic equation. For quadratic equation, x equals negative b plus or minus a square root b squared minus 4 times a times c all over 2a. But what we really care about is this part, okay? So this part, if it is negative, then that means that we would have an imaginary number. So let's set up this as an inequality, less than 0, right? So if it's less than 0, it's going to be a negative number. So we would have b squared, which again, we don't know what b is, so we're just going to keep it as b squared minus 4 times a. Our a is -1, and our c is -676. And we want to see what b would have to be in order for this to be less than 0, in order for this to give us a negative result, because it's asking what is the greatest possible value of b. So we will be able to find that limit by using a less than symbol. So we've got b squared, and then when we multiply this, we're going to get, let's see, 4 times 676 is 2,704. So we're going to get a negative 2,704, right? Because a negative times a negative times a negative, that's going to give us a negative. is less than 0. So if we add that to both sides, 2704. So then that gives us b squared is less than 2007.04. And then we do want to find the square root of both of those numbers. So b has to be less than, so what's the square root? 2704 is 52. So then b has to be less than 52. And it did tell us that it is a positive integer. So we can't use any decimals or anything. So then the next integer down is 51. So b would have to equal 51. That's the highest it could be. If it goes any higher than that, then we get into a situation where we would have a positive discriminant. So let's go on to the next problem. 22, we've got a graph here. If a new graph of 3 linear equations is created using the system of equations shown and the equation x plus 4y equals negative 16, how many solutions, xy, will the resulting system of 3 equations have? All right, so we've already got 2 equations, graphed on here. It looks like these two together have a solution of 8, 2. So really, our answers are either going to be 0 or exactly 1. We're not going to have 2 solutions because whatever this line is, it would have to go through that point in order for it to have a solution. Because a solution of even 3 equations, they all have to meet in one point. So it couldn't be C or D. We can already eliminate those. But now we're just testing, is it 0 or is it exactly 1? Does it go through this point or does it not go through this point? That's what we're trying to answer here. So let's graph it. Let's change this equation around so that it's in slope-intercept form so we can graph it more easily. I guess we could find x-intercepts and y-intercepts, but I think I'd prefer to change it to slope-intercept just so that we can see if it does go through this point. So we are going to subtract x from both sides, giving us negative x minus 16, divide by 4, so y equals negative 1 over 4x minus 4. So we've got a y-intercept of negative 4. I can already tell this is going to have no solution because we've got a negative slope. So we're going down 1, 2, 3, 4. There's no way that this is meeting up here and going to intersect these other 2 lines at this point. We can tell from the slope. In fact, I'm pretty sure that this line and this line are parallel to each other. 2, 3, 4. And we could verify that by finding the slope. Yeah, this also has a slope of -1, +4. So this one has 0 solutions because they don't all 3 meet up at the same point. All right. On to our last page, and we just have 2 problems on this page. So let's go ahead and start off here. The function f gives the value in dollars of a certain piece of equipment after X months of use. Okay, so this X represents the months, which makes sense as being divided by 12. If the value of the equipment decreases each year by P% of its value the preceding year, what is the value of P? Okay, so in growth and decay formulas, whatever is inside our parentheses here will represent how much whatever it is that we're counting grows, in which case it'll be a number higher than 1, or how much it decays. So it'll be a number lower than 1. This 0.64 represents that 64% of whatever it is that we're counting is what will remain the next year, right? So we're talking about year after year. I know that we've got x divided by 12, so that gives us month after month in this case. So I can see here that this answer is there to trick us because this looks like it's decreasing. Maybe perhaps it's decreasing by 64%. However, the 64% is what's remaining. So what we have to do is subtract that from 1, or we could do 100 minus 64 if we're just speaking in percentages. But we need to subtract this because that's how much it's actually going down each year. That's how much we're losing each year of, I don't know, whatever it is that we're counting with this piece of equipment. So when we go ahead and subtract this, we're going to get 36. So this is decreasing by 36% each month. All right, let's go on to 24. We've got a dot plot here. The dot plot represents the 15 values in data set A. Data set B is created by adding 56 to each of the values in data set A. Which of the following correctly compares the medians and the ranges of data sets A and B? Okay, let's talk quickly about what a median is and what a range is when we're talking about data. The median is the middle. It's the middlemost point. So in this data set, we could go through and find the middle point. Let's see. So this one, I'm crossing off one of the highest numbers and then crossing off one of the lowest numbers to work my way down to the middle. So 23 is the median of this data set. If we added 56 to every single one of these numbers, every single one of these numbers would be 56 more. So that means that our median would be 23 plus 56. So 79 would be our new median for data set B. But let's talk about what range means. Range, we would take the highest amount and the lowest amount and subtract them. So our range for this data set is 26 minus 22, which is 4. Now, if we add 56 to both of those numbers, then we're still going to get a difference of 4 for that range. So let's see which one of these answer choices would have the median would be higher by 56, but the range would stay the same. The median of data set B is equal to the median. Okay, that one's already out because the medians are not equal. The median of data set B is equal to the median of data set A. Nope. The median of data set B is greater than the median of data set A. That part's true. And the range of data set B is equal to the range of data set A. That is true. And then for D, the median of data set B is greater. That's true. And the range of data set B is greater. Not true. The range would not be greater. The range would be the same. So we're looking at C for that one. All right. Well, thanks so much for joining me on this live stream tonight. I hope that you were able to get some help and get some support out of this for your PSAT or your SAT practice. I will be doing one more next week for both PSAT and SAT. So join me for that. If you're watching on the replay, please leave me a comment. Let me know what you thought. Are there other things that you would like to see? I will be returning to regular algebra and pre-algebra skills. So if you've got anything that you've been working on that you would like for me to include, then let me know in the comments. That would be great. I am offering online tutoring. I have a couple of spots left open. So if you're looking for some more support in math in general, then feel free to reach out. And yeah, thanks again for joining me. I'll see you next time.